Hello, and welcome to Check on Learning for section 4.5. As you can see, we are at home, so we have some visitors. But I don't think she can help us do math. But that's okay. Ugh. So let's get started here. So remember, this is about dividing polynomials and synthetic division. So here's my chance to figure out whether or not I learned anything from this lesson, because, it's synthetic division. So, which of the following correctly explains how to use synthetic substitution to find -3, given p of x equals all of that? So this is just a kind of a conceptual question. Remember, for synthetic substitution, we would do the different coefficients. That would be 1, -1, -1, 0, because there's no x, and then -2. So that's how we'd set it up. We don't have to do that for this problem. We just have to say, set up a synthetic division with -3 in the synthetic division array, and the set of coefficients consisting of 1, -1, -1, 0, 2. So that one right there. All right, so now use this information to answer parts A and B. Find the quotient and remainder of that function. So first of all, go ahead. We need more white space. More space to do math. So this is our standard, divide problems. So because it's not a simple linear factor, you will need to do long division. I'm sure you can do it with synthetic, but I just don't know how. So we're going to set that up. So x squared minus 4x plus 1. I made lots of space for us. And then that's going to be 3x cubed minus x squared plus 0x plus 5. So let's see here. Let's make this a little bit more straight. Just for fun, we'll switch colors. So the first thing we got to do is figure out how many times this is going to go into our first 3 factors. So if I said, looks like 3x, so I'm going to put the 3x in the x spot. So 3 times x squared is going to be 3x cubed. 3x times -4 is 12x squared, and 3x plus our times 1 is just going to be a plus 3x. So just like you would with normal long division, you were going to subtract that. So I'm going to put a minus, plus, minus, or add the opposite. So that's going to be 0. Negative x squared plus 12 is 11x squared. Then 0x minus 3x. So there's our answer. So then we're going to bring our 5 down. And we're going to switch colors. So now how many times is this going to go into here? So that is going to be, what, 11? So we're going to put plus 11 up here. So we're going to say 11 times. So 11 times this polynomial. We're going to put that down here. So 11 times x squared, 11x squared. 11 times -4x, -44x. 11 times 1 is 11. So remember, we're going to subtract that. So I'm going to change the signs of all of them. That goes away. Negative 3 plus 44 is a positive 41x. And then 5 minus 11 is a negative 6. So here we have our answer. This is our answer. And this number down here is our remainder. So again, they want to give our answer in the form of dividend equals divisor times quotient plus remainder. So let's see here. Our dividend is our original function. That's going to be 3x cubed minus x squared plus 5 is equal to the divisor. That's this guy. X squared minus 4x plus 1 times our quotient. That's this guy up here. 3x plus 11 plus our remainder, which is 41x minus 6. Sorry, I ran out of room there. So this is what you would type in to here. I'm not going to do that because y'all don't need to watch me type. I think that's kind of a waste of your time. But this is what they want our answers in, because it has our dividend, divisor, quotient, and remainder. So there you go. All right, moving on. Oh, and they want us to check our work. Come back, original equation. So to check our work, you're going to multiply all this together. Oops, I accidentally deleted part of it. You're going to multiply all this together and make sure it equals that. So let's do that after I make some room here. All right, so when we multiply them together, so I'm going to start up here in black. So we've got x squared times 3x. So we got 3x cubed. So we're on the right track, I guess, at least. And then x squared times 11 plus 11x squared. X squared, and that's it. So then negative 4x times 3x is going to be a negative 12x squared. Negative 4 times 11, negative 44x. So then we're going to take we have to do our 1. So our 1 times 3x plus 3x, and then our 1 times 11 plus 11, and what the heck was our remainder? Wasn't it that one? I accidentally deleted it. Sorry, guys. I think that was the right one. We'll see. Plus 41x minus 6. So then you're just going to start combining like terms. So we've got our 3x cubed, and we've got an x squared, and that's it. So that's going to be plus a minus a 1. So minus x squared. And then, is that going to be right? So I'm going to go back up here, see what our original, yeah, so we're on the right track. Woo! Thank goodness. So then we've got our negative 44x, 3x, 41x. This is the part where I think I got the right numbers, but we're about to find out. So 3x plus 41x is 44x, which equals negative 44x, I guess is the opposite, so they just all cancel out. Neat. That's kind of sort of what was supposed to happen. So then we look at our x to the 0th power, or our just regular numbers. 11 minus 6 is plus 5. So is that the right thing? Bam. There it is. Answer checked. So these little guys, let's see here, what do they want us to do? So this part is this part right here. So then we need to add this part. So was that 3x plus 11? And then this part was our remainder that I accidentally deleted, but when I checked my answer, I figured out that was the right one. So then what did we do? So now we got to find their option that's closest to this step right here. So it starts with a 3x and it has a bunch of numbers. Looks like they already combined all their x squareds. So we're looking for a 3x minus x squared, right? Yeah. 3x minus x squared, so that's this one right here. And then we further combine the remainder into it, and we get that one. So there you go. All right. So use this information to answer parts A and B. Ooh, we get to use synthetic division. So I tell us specifically to use synthetic division, so here we go. First, we gotta set it up. So we're looking at our divisor. Remember, I remember it with, if we equal that to 0, what does x have to equal? So x has to equal negative 2. You can also just remember it is the opposite of that, whatever makes you happy. But either way, negative 2 is going right there. And our coefficients are going to be 3, 1, negative 22, 1, negative 8. So this one comes down. So 3 times 2 is negative 6. So then we add right here. So that's going to be negative 5. So then negative 5 times 2, negative 2, is going to be a positive 10. So negative 22, we're going to add down. So that's going to be negative 12. Negative 12 times 2, negative 2, is going to be a positive 24. You can all probably hear my toddler in the background. It's more fun that way with toddler noises. So 1 plus 24 is going to be 25. 25 times negative 2 is negative 50. So then we add right there, negative 58. So again, This is going to be our remainder. This is going to be our regular number. This is going to be our x squared, and our x cubed. So, let's see, what do we need to enter in? So, they have this part kind of written for us. So we just have to enter in this guy plus the remainder, or in this case, minus remainder. So here we go. I will type this in so you can kind of see it, and it gives you a chance to process. 3x to the power of 3 minus 5x squared minus 12x plus 25. So then we're going to close parenthesis and then minus 58. I think. Yeah. And of course, we get to check our answer. So do they at least give us everything we need? Yeah, okay, so I don't have to write anything down. By the way, I figured this out as I was doing the problem. In case you don't believe me, hey look, they give you the answer for part A right there. How nice of them. Anyway, let's check the answer, figure out what goes where. So we're going to do, let's just do our x's first. That's going to be pretty easy. 3x4 minus 5x cubed minus 12x squared plus 25x minus, no, not yet. So that was our x. In red, I'll do the R2. That's going to be plus 6x cubed minus 10x squared minus 24x plus 50 minus 58. So now we're going to combine like terms. At this point, we can we find at least one answer? Maybe, is this the right one? 3x, 6x cubed, minus 5x cubed, minus 10x squared, minus 12x squared, minus 24. Yeah, so I think this is, let's see if there's a little bit more to it. Yeah, there's a little bit more to it. And then the plus, or the minus 58 is at the end. So then we combine like terms. Let's see here. So 3x to the fourth. We've got an x to the third, so that's going to be plus x cubed. We've got an x squared, an x squared. They're both negative, so minus 22x squared. Whew, running out of colors, man. 25x, 24x, so plus x. And then our 50 minus 58 is going to be minus 8. So that is what goes in our next box. So that's this guy right here. Maybe in the next problem they'll give us the answer too. Which of the following correctly states whether x plus 1 is a factor of that, and if it is a factor, states the remaining factors of p of x? I don't know. So this is a situation where synthetic division is actually kind of useful. I begrudge to say, but whatever. Hi. Nobody likes synthetic division. I'm just kidding. Synthetic division is great. So this is going to help us figure it out. So we're going to set up our synthetic division looking at this guy right there. So the synthetic division is going to have a -1. And then we're going to, whoops. So, sorry, technical difficulties. So then we're going to go with our coefficients. 1, 1, 2, -4, 3, 2, 1, 0. Okay. Just want to make sure I got all of them. So the 1 comes down. 1 times -1 is -1. 0. 0 times -1, 0. Added 2. 2 times -1 is -2. Or 5, 6, -6. So this is our remainder. So x plus 1 is not a factor. I'm just double checking my math real quick. Yep. X plus 1 is not a factor. So that is one of those moments where synthetic division was super helpful because I was able to quickly figure that out. So show that the set of polynomials is closed under subtraction. Let a x of m be the term in the polynomial p of x, and let b x of m, x to the power of n, be a term in polynomial q of x. Drag the expression into the box to correctly model the situation. You may need to use expressions more than once. So we've got p of x, which has a of x, a times x to the m, minus q of x, which has bx to the m. So there is an example in the book that's very similar but uses addition. It should be the same sorts of concepts. So we've got this. So in that quotient somewhere, we should have an ax to the m power minus a bx to the m power. So once we have that, we can factor out an x to the mth power. Then we just have a minus b times x to the mth power. Since the set of real numbers is closed under subtraction, blank is a real number. So a minus b is a real number, and thus, is a monomial. So I would say this is a monomial, because remember, monomial is just a number times an x. Similarly, each term of the difference, whether the term results from subtraction, like term, or there was no like term for it, is a monomial. Therefore, the difference blank is a polynomial. So by the definition of closure, a set of polynomials is closed under subtraction. Therefore, the difference I would say that is still a polynomial. This last one I'm unsure of, but I'll check the answer. So, there you go. I'm going to go check my answers real quick, and I'll let you know how I did. Hang tight. Hey, I promised you that I would double check those answers, so here they are. So for our first one, set up the synthetic division with -3. I think that's what we had. So we're good there. Item 2, it gave us the answer in part B, so there's that. But here are the answers for part B, just to make sure. Again, I think we got that one right. The only one that I was unsure of was the last one. So here's item 3. Set up in their weird fashion, which it makes a lot of sense why they do it. It's just weird. I don't know. Part B. Item 4. X plus 1 is not a factor. I was surprised they made it not a factor, but whatever. And then item 5 was one that I was concerned about. So I was unsure of this guy right here. I didn't know if this is what they were talking about, but it was what they were talking about. So you're good to go. On that note, have a great rest of your evening, and I'll see you in class.